Chapter 14, when to use an ice table. That'll be, just to clarify that. I'm going to flip now to your reader, and I'm going to flip to the end. I think this is the end of chapter 16 to show you, to answer that question. Yeah, end of chapter 16, page 101. How's this in there? These are the type of problems you use the ice table for. Pretty much anything in chapter 14. And the key words you're looking for are equilibrium concentration. Yeah, or equilibrium pressure, or total pressure. Okay. For chapter 15, anything that says a weak acid or weak base, a salt or ion that is acid or base, not a neutral, but a salt or ion that's acid or base. That would be like KCN in the previous example, was by itself. Or a weak polyprotic acid. All of those, if you're finding pH or equilibrium concentrations as your keywords, that's an ice table. Chapter 16, common ions, buffers, and certain points in the titration problem where no titrant is added or the equivalence point, use the ice table. However, the common ion and the buffer, in most cases, those are buffer problems. You use the short form of the ice table, which is just the Henderson-Hausbach. Okay? So that's when you would do that. Yes?
So for the titration problem, if you did add it on the titration each time, like you would make C.
If I add a different amount of titrant each time, and would I use the ice table? If I'm at no titrant added, yes. Or if I'm at the equivalence point, yes. No other point would I. Like the buffer region, you're just using the Henderson-Hausbach. In strong acid or strong base region, you wouldn't need an ice table because you have excess strong acid or base. Yeah. So it depends what region you're in. Yes?
Are we going to cover how to calculate the equivalence point for the test?
To calculate what?
The equivalence point?
How to calculate the equivalence point. To find out if you're at the equivalence point, the millimoles of acid will equal the millimoles of base. Is that did I answer your question?
So the pH does not matter?
The pH matters if I ask you, but I'm only asking a simple question on exam 2 about titrations.
Can you later on cover indicators?
You can ask me at the Q&A time about indicators, but it's too late to add on, unfortunately, because we're not even going to finish what's on our list right now. But you ask me in the Q&A time. Okay, let's do a couple more of these. I want to do K. What types of Ks are there? Okay. Several different types of Ks. Equilibrium. Kc and Kp. Kp died and nothing else happened to it ever. But Kc was prolific like a rabbit. And so Kc, there's many Kcs. Ka is a Kc, Kb, Kw, Ka1, Ka2, Ka3, and then everything else in the next chapter are all going to be Kcs. Okay? So these are all Kcs, but you want to always recognize and use the right K for the right reaction. So when you're looking at the reaction, you want to decide which one of these Ks am I using. Okay, so that's all I have to say about Ks. The Chatelier's principle. Let's assume these are all gases. This is our Haber process. And this is exothermic. Okay, for this, and there's 2 here. For this exothermic reaction, let's say I increase the temperature. Which way will this shift? Right or left? Increase the temperature. Shift right or left? Yeah, exothermic means plus heat here, so it's going to shift left. So there's several things that will cause. Oops, it's a little hard to see there. It's going to shift left. That means the NH3 concentration will go down. Both reactants will go up in concentration. Will K change? Oh no, that's too crazy. I'm not going to ask you about K. Yeah, K could change if temperature changes. Let me ask you about Q. Will Q change? I like this question better. Will Q change? You don't need to even go to temperature to answer this question. Will Q change? Okay, if you say yes, you have to tell me if it's up or down. If you say no, then you don't have to say anything else. But you may be wrong. Q is what? How do you calculate it? Products over reactants. Is the value of products changing?
Yeah.
Yeah. Is it going up or down? Yeah, the amount of products is going down when it shifts left. The amount of reactants is going up. So is Q going up or down? Down. Yeah, Q is going down when it shifts left because there's less products. And Q is products over reactants. Okay. If I increase pressure, which way does this shift? Right or left? Remember, increased pressure is the same as decreased volume. Less volume will shift which way? To the right, the smaller side. Yep. Okay. If it shifts right, now I can ask you this question. Will K change?
No.
K is not going to change unless temperature changes. Okay. Will Q change? It will. Yeah, now you're used to saying yes. Okay. And is it going to go up or down? It has to go up because if it shifts right, I'm making more products. And Q is products over reactants. So if there's more products, the value of Q has to go up. K doesn't change.